accidentally oversteep one of your favorite teas? And then you get kind of a dry mouth and your saliva stops flowing normally? That's exactly what astringency is. But what is this? Why does this happen? That's what we're going to look at today. Astringency is not a taste and it's not a flavor. It's actually a physical sensation to some chemical interactions that are happening inside of your mouth. And we're going to take a look at that so you can get a good visual on this and start to understand what astringency truly is. Now it's time to draw one of my absolute favorite tea molecules. It's called theaflavin 3,3' digallate. It's a pretty big one. It has a lot of elegant parts to it. Okay, we're getting close to the end. So just a few more parts to go. Okay. The reason I drew this big monstrosity of a molecule is this one is particularly astringent. Well, why is that? The astringency comes from the parts of this molecule that are chemically sticky. Specifically, there's a lot of them on here, but specifically the ones we're going to focus on are this part. These are O for oxygen and H for hydrogen. And you'll see there are quite a few of them around this molecule. So why does that make things astringent? Your saliva is around 99.5% water, and the other 0.5% is salts and some proteins and some other things. So salts, proteins, and water are also all chemically sticky, and that's where the problem comes in. It's the chemically sticky interactions between your saliva and this molecule that cause astringency. So let me draw that for you. All right, so here we've got this chemically sticky part on the molecule, and then here we've got a water. So this water here is sticking together to the molecule. Well, that's water in your saliva. And then we've got another water over here, and then we've got a protein here. Proteins are incredibly difficult to draw, and this is not to scale. I'm just using the squiggly line so you get kind of an understanding of it. So we got another protein over here. We've got waters, millions and millions of waters everywhere, and all this is binding up into kind of a molecular traffic jam in your mouth. So you've got parts here and parts there, and they're all drawing that saliva, and they're stopping its normal motion across your tongue. So your tongue is no longer hydrated. That's exactly what astringency is. So this is a 2D representation. Let's take a look at a 3D representation. This is the most tongue-shaped plate that I could find. So this is supposed to be your tongue, and this is your saliva. These cut up sponges, little pieces here, this represents the astringent molecules. And what this is going to do is exactly what it does in your mouth. As soon as this hits your saliva, it's going to start absorbing it. You see that the color of the sponge turns from yellow to orange as it absorbs the colored liquid. So now, Once the water stops flowing and your mouth starts getting dry and everything gets stuck together, that's exactly what astringency is. Not a big deal though, because under normal processes, your tongue and your salivatory glands are going to make more saliva and going to make your tongue moist and hydrated again. And if you're in a bigger hurry, go ahead and just have a sip of water, because that should wash away the majority of the astringent molecules. So now we've got a good grasp on astringency, and we'll touch on a lot of other molecules and a lot of other topics in future upcoming videos.